Compound events are when two or more simple events happen together. So they're like happening simultaneously at the same time. And they can be independent or dependent. Independent events are when the probability of one event does not affect or doesn't change the probability of another. So for example, if I spin a spinner and roll a dice, those are two independent things. They don't affect each other. Or if I flip a coin and then I flip the coin again, just because I got heads on the first flip doesn't mean that I can't get heads on the second flip. Like flipping a coin always has a probability of 1/2. Or even like I draw a marble from a bag and I put the marble back in the bag. What's the probability that I draw that same marble again? It's the same. Like because I put the marble back in the bag, my total amount of marbles stays the same. So those two drawing of the marbles would be independent. Versus a dependent event would be if the first event somehow changes the probability of the second event. So for example, if I have a deck of cards and I pull out a king, what's the probability that my second card is a king? But if I don't put that card back in my deck of cards, I've changed the total number of cards. So my first draw I had all 52 cards, but because I didn't put that card back in the deck, my second card is only out of 51 cards. So usually dependent events are like if you take something out or remove it and you don't put it back before you draw again. So the probability of two independent events happening, it's just the probability that the first thing happens times the probability that the second thing happens. The probability of two dependent events would be the probability that the first thing happens, and then the probability that the second thing happens, granted that the first thing already happened. So it's because the first event influences the second event. This is like the probability that the second event occurs knowing that the first event already occurred. So it's the probability that event B occurs given that event A has already occurred. So in the first example, we have 10 red marbles and 8 blue marbles. Suppose Josh draws a marble and he doesn't like the outcome, so he puts it back. Super important. He puts it back and he's going to draw a second time. What's the probability that on each draw his marble is blue? Okay, so we have 10 red, 8 blue marbles for a total of 18 marbles. So the first time he draws a marble, what's the probability that it's blue? It would be 8 out of 18. And because he's going to go put this marble back in the bag, the second time we go draw a marble, it's still going to be out of 18 marbles because I have all 18 marbles in my bag. So I'm going to still have 8 out of, like the probability of drawing a blue marble is 8 out of 18 because I put that marble back into my bag. So I haven't changed the number of marbles. So these are two independent events because drawing a blue marble the first time doesn't influence me drawing a blue marble the second time because I put it back. So I'm just going to multiply 8 times 18 over 8 times 18, which is a fully reduced fraction, is 16 over 81. On our second example, what's the probability that a red marble is drawn from a bag of 2 blue and 5 red marbles and not replaced, and then a second red marble is drawn? So the first time I'm drawing a marble, I have 2 blue, 5 red, so 7 total marbles. What's the probability that I draw a red marble? So I have 5 red marbles, 5 out of 7. But I am not going to replace that marble. I'm going to hold that marble outside of the bag. Not going to put it back in the bag. So when I draw my second marble, I only have 6 marbles in my bag because I held on to that marble I drew the first time. And that first marble was a red marble. So I don't have 5 red marbles in my bag anymore. Now I have 4 red marbles. So I removed a red marble, so my number of red marbles decreased from 5 to 4. So the probability that I drew a red marble the first time was 5 out of 7. Then because I didn't replace that marble, now I only had 4 red marbles and a total of 6 marbles. So these two events are dependent because the probability of drawing the second red marble depends on what happened with the first draw, because since I'm not replacing that marble, I've changed the total number of marbles and I've changed the total number of red marbles. So this will give me 20 over 42, which reduces to 10 out of 20.